ya. Hope you have a great day. That was terrible. Oh my god. Anywho, this is algebra notes for 8-2 arithmetic sequences. And yes, I do know that that word is also pronounced as arithmetic. It depends on the way you use it. Bless that English language of ours, you know. So if you're using it as like a verb, like arithmetic is what you do, like adding, subtracting, that's arithmetic. However, here we're not using it as a verb. We're using it as a as like an adjective, as a describing piece. And arithmetic, I feel like I need to look that up. I feel like I might be. I'm pretty sure it's an adjective. Yes, I'm right. Proud of myself. So as a verb, it's arithmetic. As an adjective, it's describing something. It's talking about a type of sequence. So that's what's going on right here. This arithmetic piece is just talking about a type. Well, that's not cool. How about that? Oh, never mind. There we go. So arithmetic is just talking about a type of sequence. S-E-Q-U-E-N-C. Boom. Okay, type of sequence. We're going to look at two main types of sequences. We're going to look at arithmetic sequences today and then geometric sequences tomorrow. So an arithmetic sequence is a type of, just like we learned yesterday, that sequences are a discrete function. So arithmetic sequences are a type of function, a type of discrete function. They are a type of discrete linear functions. So the new part here and the most important part is that they are representing linear, discrete linear functions. Remember from a previous lesson that the discrete part, the fact that it's a discrete function, that tells us, A, when we're graphing it, we don't connect those points. And that's because there's not an infinite number of them. It's not all numbers. Think about how I want to word it. It's only those integers. That's why we do not connect the points. Not all numbers. Okay. So linear, hopefully something should be going through your head when you're thinking about what it means to be linear. If we're talking about a linear function must have a constant rate of change. So there is a constant rate of change. AKA, constant rate of change is just another fancy name for a slope. Right? We've got all these different names for that. And what that means, what a constant rate of change actually means, what a slope means, and when you're going to be looking at your sequences, you're going to be looking for that, adding or subtracting by the same amount each time. So that's the pattern that you're going to be looking for. You're going to be looking for, I'm adding 7 each time to get to the next piece. I'm adding 4 each time. Just like we found out in previous examples. We were adding 6 each time to get to the next piece. So this is an example of an arithmetic sequence. We could go back in and jot that down real quick, that this is arithmetic. I can't spell arithmetic without thinking about it as arithmetic. Okay. So here we go. So that adding and subtracting by the same amount each time, that is my constant rate of change. That is my slope. Our new fancy name for that constant rate of change and that slope is that common difference. Common difference making complete sense because if you think of difference, the word difference in math tells us to subtract. So common difference deals with that adding and that subtracting. So normally, previous to this, we've been using, m to represent our slope and that y equals mx plus b. But now, because we can't make things easy for you, for a common difference, we're going to be using the variable d instead. So whenever you see d, just know that all three of those, d, slope, m, they're all the same exact thing. Constant rate of change, common difference, all the same exact thing. Okay, and so then there are, formulas or equations that we use for these linear functions. You guys know your linear function as that y equals mx plus b. But remember now, we're not using y and x anymore because we're talking about sequences, and they like us to use that a and that n. So I've got my a of n, because I'm doing function notation first. So that's like my y. So y equals, m is my slope, which now instead of using m, we're using d for my slope. Instead of x, we have n. And this b right here, that b represents the y-intercept. And remember, we talked about it yesterday very briefly in our previous lesson, and we're going to write it again up here, big star, that a sub 0 is the y-intercept. Not a sub 1, not that first term. It's the 0th term. Okay, so then that y-intercept, we're just going to add on that a of 0. A sub 0 is the same as a of 0. One's just function notation. The other is sequence notation. So that's function. And then down below, I'm going to write the same thing, but I'm going to put it in sequence notation. So instead of a of n, it's that a sub for that subscript n. And then actually everything else basically stays the same. And instead of a of 0, it's a sub 0. And that is just your sequence notation. And again, each of these pieces is just your y equals mx plus b. Your slope and your y-intercept. Okay.